Hi class, we need to take a look at how to evaluate probabilities from the actual normal distribution. And this is what you have. So technically your bell-shaped curve or normal distribution has this formula. Now the formula is really not needed because we're not going to be actually evaluating it directly. We're going to be using the shortcuts. And technically all of these will have the arrows on both of the extremes, since theoretically the distribution actually is infinite, since we're talking about a population. Now let's take a look at example 1. And for all of these problems, they're going to be asking the following. So they want you to evaluate the probability, and technically it is understood that probability in area happens to be the same for the terminology that we're going to be talking about in the next sections. They also want us to take a look at the table. I'll show you how to read the table and provide sketches of the probabilities. Now, for all of these, since we're talking about the normal distribution, your random variable or the actual x values here are going to be technically z-scores. So on all of these, you would first say, let z be a random variable. So let z equal to a random variable. And all it means is technically z is going to be representing the number of standard deviations above or below the mean that we're going to be doing the sampling from, or the probabilities. Now, the first problem that they're asking about is below below z is equal to 2.3. So technically, if we were going to express this as a probability and you translate it exactly as well it reads, in this case, this one says z is less than 2.3. Now, because of a technicality, any problem that says less than for the normal distribution, you're just going to say that this is z is less than or equal to 2.3. So you can technically start the problem on this portion, because since the random variable happens to be a continuous random variable, meaning it represents standard deviations above or below the mean. So technically those could be any numerical value on the number line. Less than in this section is understood as less than or equal. Now, if you're going to be making a sketch of this particular scenario, let me just put the arrows here. This is the value of 0, since technically that represents the mean there. 2.3, I'm just going to say that's 1, and I'm just going to put this to scale. Not to scale, I mean, but 2.3, it's going to be around here. And what they're asking on this particular event is that we get the area to the left of 2.3. Now, the area to the left, the way that they're actually expressing it means all the way to the negative infinity. So you're getting the entire area all the way to the left, and we're going to find this via two methods. Now, we technically are not going to be evaluating the formula directly. We're going to be using the shortcuts. And let me show you where to find the shortcut on the calculator for this specific scenario. So in your calculator, you're basically going to activate the following command. So you're going to go to second in distribution, and then you're going to activate the normal CDF. Now, the normal CDF, it's going to work based on the following parameters. It wants, well, from where to, from left to right, where does it start and where does it begin? And what we typically use on this distribution is a very large value on the negatives, so negative 100, and then we're evaluating all the way to 2.3. Let me just verify the problem. And do not modify 0 and 1. We'll talk about that when we're doing the applications, and then just run it. Now, in this scenario, the probability that the z-score or the area to the left or the z-score is less than 2.3, that's about 0.9993. So 0.9993. That would be the actual probability that the z-score is less than 2.3. So I'm only using the negative 100 here to emphasize the negative infinity, and then it goes all the way to technically 2.3. So that would be the code. On a future exam, you would just say, if you're using the calculator, since I won't see you running it. So let me put the code here. And this will be normal CDF negative 100 to 2.3. In there, you do have to put that the mu is 0 and technically 1, but those come as default values. And that is when we actually did the running of it, they were already there. So your normal CDF, mu and sigma are already there. So you don't have to modify them. So technically that is the area to the left of this specific z-score, 0.9993. Now, it's not the only way to find this probability. They may ask you to find the table. So the table is going to appear in one of the pages in the module for this week. And let me show you the table. So this is technically the table that we use to read or to find probabilities. And notice that, well, this shaded area only works to the left of the z-score. And let me show you how to read it. So the probability of the event that they're asking us to do or evaluate here is technically to the left of 2.3. So this is how you're going to read it. So you could start on the left, negative z-scores, but 2.3 is positive. So that means you're going to be here. 2.3, you're going to read it like this. So technically this is in the column of 2.3. We're looking here, and that is your value. So it's going to be along the column of the 0, 0. So that would be 2.3, 0. So 0.9893, which I have here. And in this case, 9893. Let's see if we match with the, whoops, did I miss, oh yeah, I wrote it wrong. So it's 98. This is supposed to be at 98. $93. That's from the calculator. You can actually confirm it here on the table. This is the 2.3, 0.9893. Once again, it's in the column of the 0, 0 for 2.3. So it's reading it as 2.30 on the table. Just one more comment on this actual table, and that is that the table only works on problems to the left.